It's not a question of resampling. It's a question of once the remediation is actually working, you'll be able to run that sample at a lower detection limit. By just taking a high concentration and diluting it and diluting it and diluting it to the point, the actual results you will get will be meaningless because they've been diluted to a certain level. This right here, when the lab says, hey, we can get it down to 20 U, that's a judgment call based on the lab, not the Navy. This is the laboratory making a decision based on their instrument. This sample, what is the best way I can actually achieve to give realistic results off that sample? You can't say, hey, I want to get to a certain level, because you could actually wind up diluting it to a point where it's meaningless at that point. So you can say, hey, well, you really haven't quite yet met your cleanup goals on this one. And you would be accurate on that, and he's not done.
Yeah, this is just the first, this is just, as I said, this is the first sample that we took. This is the first water
undetected. Right, it's non-detect to a certain, so you have a reporting limit.
So
and
it means that you don't have to worry about it anymore because it's undetected.
No, absolutely not. It's undetected to that concentration level. So you have what's known as a method detection limit and then a reporting limit, which is another form of a detection limit. That's how you get that J and that U. So a method detection limit is, you have an EPA method for a certain analysis. 8260 is real common for your VOCs, okay? And they have a certain method for a VOC and 8260 run that those machines can hit. But then you also have reporting limits. And the reporting limits come into play when you have samples that are sometimes higher than a machine can handle, and they have to do things like dilute it. And when you dilute it, as a function of that, you get a higher reporting limit. That's how sometimes you see things in terms of J and U. That J means it was a value between the method detection limit and the reporting limit. Sometimes they have to adjust that reporting limit based on the sample that the lab receives.
What we can do is we can give you an explanation of how these samples are, what that means, because they have these are certified labs, and they have their own detection limits set with those.
Yeah, this is what we should have done, is what we usually do, is put ND. It simplifies things.
I think I can add, we have a lab, and we have a lab liaison that helps us understand these things. And a U is for dilution. But I think I could probably get a simple definition from our lab that explains what they do when they need to dilute a sample and why they need to dilute it. But the point being that when they have to dilute it, then that detection limit changes. So the number here of 15 was adjusted. And so even though it shows 40, it's really below the detection limit that was required, so therefore, but they still had to flag it because they diluted it.
But it's not in red, which means it's not.
So I could get a simple explanation from our chemist that I can provide that kind of explains it clearly. That might be easiest way to do it.
Especially because they do modify their results. They just did it at Hunter's Point, they just wiped out the rest.
This is a common practice that is done by the lab, by the chemist.
But it means that they can walk away from it.
No. There was some type of interference or something that they had to dilute the sample. This is very common, it happens all the time.
It's been done for years.
And it's up to the lab, and it's up to the chemist.
We have been told this for years, and what we have been told is the J was, what was the J?
The J is flagged, but the U is when they do a dilution.
No, we were never told about dilution before. We were told that the machinery could not detect it accurately. That's what the U is, and I forget what the J
Yeah,
is.
I don't know
But
what
that's
you were
what we have
told
been
in
told
the
for
past,
years.
but this is very common, and I have it on many of my sites, that
We
they
have it
have
all
to
the
do
time in
this.
these documents, and we don't normally worry about it.
You've never seen a U
Correct.
before?
Oh, no, no, we see it all the time.
We don't normally
Okay.
put it in presentations, usually
Oh, you just,
we,
and you
ND,
put ND, I
correct,
see.
but we've
Because that,
sort of gotten
I
off
see.
topic.
So
by
normally
putting
when
U's
I
and
get a
J's in
report, I
presentation.
often see the U, it's always included.
Well, I see them in these documents too, but they're always explained as the U is,
Right, so-
the machinery could not detect it, and it's kind of an estimation.
Right, so it's
J
really
is
up
the
to the
estimation.
chemist.
Okay, then J's the estimation.
Right.
J is the estimation.
It's between the method detection and that reporting.
That's
limit.
all we were
So
told.
what I
this
can
is
do,
different.
if you want, is I can get a brief summary that really explains it simply. My chemist is very helpful, she helps me whenever I have a question on anything.
That's
And
fantastic.
we
That's
have the
great.
lab right there in our office, so it's very easy.
A chemist and a
you,
lab person could sum it up
yeah.
so much better than I could right now.
Thank you, Nina, that was, thank you so much for clarifying.
But just, I mean, I hate to keep going back to it, but you
No.
say one reason to dilute it was because it was so strong. And yet we measured
Not
3,500.
necessarily.
But I mean, that's what they said.
Okay, we'd have to look at the
Yeah.
lab
So
report.
Yes.
maybe
Yeah,
when it's
I'm not a-
strong.
I'm not a-
Typically, when you see that, that's what it is. When you see a U, it's a dilution factor, and they're diluting it
Okay, it's
for a
a
reason.
dilution factor, but we look over at the other wells that are much hotter and they aren't diluted.
Right.
You have a function, like I
You have
said,
to-
you need a real chemist that can
Chemist
probably
explain
succinctly, you have sometimes interference in a machine, like a sample could have something in it. It could have a particle in it, silt or whatnot. You could have all types of interference, and when they do a first run, they'll see flags. The chemist will come out and see flags and say, we need to do another run. There's a number of factors, and typically in the final lab report that you would get, that would be like in the final document that you would see to the agency in the draft report, the laboratory report would have all the notes about the U's, like why did we have to U this one, or why did we have to J? That's in the final laboratory reports as well, the specifics behind it.
Okay, so thank you, Nina. Can you get that provided and then to the RAB? Okay.
Yeah, and maybe a simple one then is on page 14 on your goals.
Yes.
You have the DCE at 46,000. And all the others are in tens or hundreds.
Where are you seeing 46,000? I'm not seeing 46,000.
In the yellow box.
Oh, okay, got it.
Is that a typo or is that?
No,
No,
that's micrograms per cubic meter.
Right.
But if you have that, the cyst up that high, then when it becomes vinyl chloride, there's going to be a hell of a lot of vinyl chloride.
Yeah.
And you're not going to meet your goal. So did you actually make that a goal that high? Because it was the vinyl
Yeah,
chloride.
that's the goal,
And
yeah.
vinyl
That's
chloride
the
is
goal.
carcinogenic.
That's the
Reaction
reaction
level.
level.
Yeah.
46,408.
Okay.
But eventually it'll degrade, what we hope is it will degrade down past that. and you-
Past
you would-
vinyl chloride.
you
But I mean, the
have to
trouble is
deal
having
with
it
it.
that high.
Correct,
All
sometimes if
this
it
has to be-
stalls,
Yeah.
but we're hoping we'll get past that.
Yeah, if you look at.
That's true, but the reason why it's higher is because everything is risk-based. So what does that tell you, not knowing anything else, what does that tell you about the DCE?
It's not carcinogenic, but it ain't going to stop there. It gets hung up on vinyl chloride.
No,
That's a
no,
trouble.
well, it
Well, that-
sometimes gets hung up on vinyl chloride,
Right.
sometimes it goes
Oh,
back.
we've been lucky, it
that's-
hasn't,
Right, right. Well, it depends, right,
Yeah.
on the conditions.
But
Right.
Okay.
we had a lot of measurements of the ethane, and ethane has spiked up quite a bit. So if you go to slide 9, you'll see that it's gone past that point. It's not hung up on vinyl chloride.
Right. No, we've been very lucky on
Yeah,
this
it's
site.
going into the ethane, and we've
But I was just
got
surprised to see that we would have that,
Right.
because I don't see how that could be the goal, because it seems like we'd be setting up for a problem.
It's not so much it's a goal, it's based on, again, as you indicated, you know, it's low toxicity. A low carcinogenic value means, since it's risk-based and it's pegged to risk, it means a higher number is allowable. It doesn't mean that it'll stay there, you know it won't, it will continue to go down the chain. And as you indicated, one of the problems potential problems with that is, if it goes down to the next level in the chain, it's a vinyl chloride, which has a much lower level because it has a greater toxicity, right? But it doesn't always go to VC, it sometimes blows past that into ethane and ethane, right? In fact, it often does that, but sometimes it doesn't. Your point being though, if you still got 46,000 left, you've got a lot of ammunition, so to speak, that could potentially get hung up at vinyl chloride, is your point. And again, we'll have to see, right? We'll have to see what happens, because now that the nutrients are taking effect, the iron has already had its bang, right? It's a very short-term bang chemical reaction. Now that you have the nutrients that were in the second part of what he injected, we're going to have to see what the bacteria do with that. They often blow it all out through vinyl chloride and over time get down to the non-toxic gases. It is very, and Dale can tell you this having been on other bases, it is very site-specific.
Yeah.
Okay.
No, we've been lucky.
Yeah.
Okay, thank
But
you.
we have been, and you're right, we have been very fortunate so far. It's good news, what we've received. But there's more monitoring, and there's a reason why there's more monitoring, right? There's more that we have to look at, right? And then you have to gauge, do you ever have to go back and do further action or not, right? You always have to gauge that after you do ZVI and in situ bioremediation. You always have to gauge, do you need another round or not? And if you do, where do you need another round? Right. Okay. Next question from the RAF. Dale?
Yeah, I do. Why, if you're a registered geologist, aren't you using your licensing on?
I'm not a registered geologist.
You just studied geology.
I'm a geologist, I'm not